This video will be about organizing data into matrices. So a matrix is a way to organize a lot of data, and when you say multiple matrices, and there's a whole bunch of them, they're called matrices. So it usually is rectangular in shape. So we have a whole bunch of data, and we're just taking the counting numbers, 1, 2, 3, 4, 5, 6. Putting it in a rectangular shape, but you only use brackets around it. And that is what a matrix looks like. They can be any size. They don't have to look exactly like that. This is also a matrix. So when you look at a matrix, it's made up of rows. So this is the first row, and it's the first three numbers here, 1, 2, 3. That's the entire first row. And it has two rows. And then columns. So this would be a column, just the 1 and the 4. 2 and 5 would be a second column. And 3 and the 6 would be a third column. So when we look at a matrix and we determine what size it is, we use how many rows there are by how many columns there are. There were 2 rows. Then we use a little x to mean by. It'll often just be said 2 by 3, but you actually read a little x there. And this has 3 columns, so 3. For this smaller one, we have 2 rows again, row 1, row 2, but this time only 1 column, column 1. So this matrix would be a 2 by 1 matrix. So when they're asking questions about them, they'll also usually give a letter name. When you give a letter name, it's going to be a capital. So capital C is 1, -3, 5, 7, -2. And it would ask something like, what size is matrix C? So you have to determine how many rows. So this time there is only 1 row by, and we have 1, 2, 3, 4, 5 columns. So matrix C is a 1 by 5 matrix. So inside of the matrix itself, each of these is called an element. So if we had this matrix A, so since they're all called elements, we need a more specific way to determine, well, 1 is this particular element, or -3 is this particular element. So again, it's going to be based off the number of rows and columns. We have 3 rows and 2 columns. So to find and determine a specific element, they use this notation. It'll be a lowercase, since it was a capital A, lowercase a. If like our last matrix, it was a capital C, we'd use lowercase c. So lowercase just means this is going to be one number inside, one element inside big matrix A. So A, and then they're going to put 2 little numbers subscript, so down below. A1, 1. These 2 little numbers are referring to the row and the column. So we want the element that's on the first row and in the first column. So first row is -3, 5. First column is -3, 0, -1. The only number that's in both is -3. So if you just go over row 1, column 1, where they meet is the element A11. So you can name a couple from each matrix. Like if I wanted to say A32, that means third row, second column. So over to the second column, that would be 4. Or A22, second row, second column is +1. So let's practice one more. So we have matrix D. Okay, here's matrix D, matrix D, and we want, what is element D2, 3? That means second row, third column. So row 1, row 2, then we have column 1, column 2, column 3. So D2, 3 is 0. So those are just the basics of the notation. Now we can use actual data. So they'll have a real life example and they'll have a data with some information. So let's say the 12th graders were surveyed from a certain school and they surveyed the boys and the girls and asked who has a part-time job and who doesn't have a part-time job. And when they did that survey, they found out 70 boys have a part-time job, 25 do not. 65 girls have a part-time job, 45 do not. So when you have a table like this, it's basically already set up in matrix format. You're just going to take it out of the table and put the brackets around it. So our matrix is 70, 25, 65, 45. So from that matrix, I could ask, what is element J? Oh, I'm going to call this capital J matrix. So J1, 2. Well, that's first row, second column. So first row, second column gives you 25. So that is element J1, 2. When we say the numbers separately, we don't say J12 because it's first row, second column, so they're two different numbers. So you can use actual data that's been in a table, or you can use actual data that was in graph format. So let's say we have this graph. A store was surveyed, and for every year, they were asked how many DVDs did they sell and how many downloads did they sell. So like in 2010, the store did 100 downloads and 300 DVDs. Now, when you make your matrix from a table, you do need a little more information. So we need to know, are the years going to be the rows and the type the columns, or is it going to be opposite? Is the type the rows and the years the columns? So they do need to specify in the question. So for ours, let's make years the rows and the type, so either DVD or download, that's going to be the columns. So with our matrix, we have 4 years. We have 2010, 2011, 2012, and 2013. The types, we have DVD versus our downloads. Sorry, it's overlapping a little bit. So 2010 DVDs sold was 300, so that's your first number. 2010 downloads sold was 100. That's your second number. 2011 DVDs sold was 250. And where I drew the graph by hand, it's a little harder to tell. I did mean that to be halfway between 2 and 300. It'll be easier when it's something done on the computer. They'll have like the lines going across so you know exactly where everything is located. Downloads was 200. 2012, the DVD was 150 and downloads was 250. I think I meant that to be 300. Sorry, it's just hard to tell from my hand-drawn graph. And then 2013 was 100 and went all the way up to 400 for downloads. So you can make a matrix from an actual graph. They just do need to specify whether your rows will be the years or the types, and whether your columns will be the years or the types before you can make your matrix. So there's one more type of graph that you can do that they can make a matrix out of. So with this graph, let's say we surveyed a library and asked how many novels, biographies, and nonfiction books were checked out every week for the month of October. So week 1, there were 200 novels, 150 biographies, 100 nonfiction. So again, the question we'll need to specify, and you need to watch out for this, is, well, which ones are the rows and which ones are the columns? So we will make the weeks the rows and the type of book the columns. This is the one most often used. Usually the time amount is the rows, but it doesn't have to be written this way. So we have 4 weeks and 3 types of books. So this will be a 4x3 matrix of the different weeks. Week 1, week 2, week 3, week 4. And the different types of books, the novels, biographies, and nonfiction. I'm just going to put NB and non for novels, biographies, and nonfiction. And then we look at our data. Week 1, we had 200 novels, 150 biographies, 100 nonfiction. Week 2, we had 175 novels, 95 biographies, 110 nonfiction. Week 3, we had 215 novels, 120 biographies, 120 nonfiction. And week 4, we had 150, 60, and 85. So from this, I could ask you the matrix size, say 4x3, because we had 4 rows, 3 columns. I could ask you for a certain element. Let's say we want element A23. So that would be second row, third column, so second week. Third type of book, so 110. Or I could ask you these without even drawing the matrix. So if we took this graph itself up here, so just the graph, and I said, let's find the element A23, but I specified that the rows are going to be books, so the types of books, and the columns would be the weeks. You can find that without drawing the matrix out. So this one, this A23 will be different than what we've already found because this was when weeks were rows and types of books were columns. So if rows are the types of books and columns are the weeks, we can just go through and find our element without drawing out the matrix if we want to. We could draw out the matrix as well. So 2 is for our rows. So the second type of book and its week 3 value. So second type of book was biographies. Week 3, we had 120 biographies checked out. So A23 is 120 if the rows are the types of books and the columns are the number of weeks. So you do really need to watch out for that, which one they state, because it can change what your answer will be. So this concludes our discussion on organizing data in matrices.